Hey everybody, we're going to go through the solutions for checkpoint for module 3. So here we're using the quadratic formula, which you know by now is opposite of b plus or minus square root of b squared minus 4ac all over 2a. And in this problem, a is 1, b is 10, and your c is 9. So if we substitute these values in, you get negative 10 plus or minus square root of 10 squared, which is 100, minus 4 times 1 times 9. 4 times 1 times 9 is 36. All over 2a, which is 2 times 1. Okay, now we're going to simplify what is in the square root. So we take, this is kind of the key part right here. This is where everyone makes the mistake. Inside this radical, you have to be careful if it's minus a positive or minus a negative. And up before, we had 4 times 1 times 9. Those are all positive numbers, so it's minus a positive 36. So in this case, we have 100 minus 36, which is 64. So this is looking to work out nice and neat. We have negative 10 plus or minus the square root of 64. All over 2. Alright, well, square root of 64, that's a perfect square, 8. So that is the same as negative 10 plus or minus 8 all over 2. This tells me that when it comes out perfect like this as a perfect square, square root of 64, that this could have been factored. And if you look up from the beginning, yeah, this could have been factored right away. So quadratic formula really wasn't the best way to do this, but nonetheless it is possible to use the quadratic formula with anything. However, if I was going to solve this, I would have factored this quadratic into its two factors, x plus 1 and x plus 9. And you know from previous lessons, if x plus 1 is a factor, then negative 1 is a root, or a 0. And if x plus 9 is a factor, then negative 9 is a root, or a 0. So if I take this and simplify this here, I will have negative 10 plus 8, which is negative 10 plus 8 is negative 2 over 2, which is negative 1. Alright, that's using the plus. If I do negative 10 minus 8 over 2, that's going to be negative 18 over 2, which is negative 9. So the two possible solutions here are negative 1 and negative 9. And that does match up here with what we have with the factoring. We have a negative 1 makes the factor x plus 1 0, and negative 9 makes that factor x plus 9 0. So again, not the best method, but you certainly can solve any quadratic function with the quadratic formula. Okay, we'll take a look at number 2 now. And if we use the quadratic formula, again we have your a, which is 2, your b, which is the 4, and your c is the negative 12. So don't forget, if it's subtracting, the negative applies. So we have the opposite of b, which is negative 4 plus or minus the square root of b squared, which is 16, minus 4 times a, which is 2, times c, which is negative 12. and that is all over 2 times 2, which is 4. 2a. 2 times a, 2 times 2 is 4. Alright, let's clean up what's inside the radical. So inside that radical, remember this is kind of the key part here. You don't want to screw this part up. So inside that radical we have 16 minus 4 times 2 is 8, and 8 times 12 is 96, but it's a negative 96. So inside that radical we end up having 16 minus negative 96. Okay, and then you don't want to forget here that if you have minus a negative, that's actually plus. So if I have minus a negative, really that's plus positive. So I have 96 plus 10 is 106, plus another 6 is 112. So after I clean that up, I have the square root of, negative 4 plus or minus the square root of positive 112. Oops. All over 4. Okay, so can I simplify this radical? What are factors of 112? Okay, well, does 112 go into 16 or 4 or 9? And so let's think about what are factors of 112. So factors of 112 would be, it's not really obvious, but 16 and 7 are both factors of 112, and 16 is a perfect square. So that means I can simplify this radical by pulling out a factor of the square root of 16. And I'll just show you all the behind the scenes action here. So we have square root of 16 times the square root of 7 is equal to the square root of 112. And the square root of 16, that's a perfect square. So this right here, this square root of 16, the whole point is to find a perfect square factor, and that square root of 16 is a perfect square, 4. So really what I have there is, and that was all over 4. I should make sure that's in there. So really what I have here is 4 plus or minus square root of 16, which is just 4. So 4 root 7 all over 4. Okay. Now this works out well because I have the ability to factor out of 4 of each one of these terms. Let me get some more room. So if I factor out of 4 in each term, I have 4, and it's kind of like the reverse distributive property, times 1 plus or minus the square root of 7 all over 4. All of it. All over 4. And what that's going to give me the ability to do is cancel out the 4's. So really, when this is all said and done, the solution is 1 plus or minus, which is 1 plus square root 7, and 1 minus the square root of 7. There's your two values for x. So there's your solution to number 2. Not rational numbers, irrational numbers, but they are real. So there was 2 real solutions. Okay, here we go with number 3, opposite of b. So b is negative 3, so the opposite of that is 3, plus or minus the square root of b squared, so negative 3 squared is 9, minus 4 times 3 times 3/4. So 4 times 3 times 3/4. Well, all over 2 times 3, which is 6. Okay, So inside my radical here, this part has a fraction. And I notice that it has a denominator of 4. So this is going to work out really slick, because if you multiply 4 times 3/4, the 4's are just going to cancel, and you're going to get 3, which 4 times 3/4 is 12/4. And 12/4, 12 divided by 4 is 3. So really, this is 3 times 3, which is 9. So what I have here is 3 plus or minus the square root of, and then we're going to have 9 minus 9, which is 0. So I don't even have a square root value here. And what that means is you're going to only have one solution, because this is going to be 3 plus 0 over 6, which is just 3/6 or a half, and 3 minus square root of 0, which is 3. So this is only, when that happens and your inside your radical is 0, you only have one solution. And in this case, it's 3/6, which is reduced to 1/2. What that means on the graph is that this function, so if I just sketch a quick graph of that, this function is going to have a vertex of 1/2, so if I go over a half, and a y-intercept of 0. Excuse me, I said y-intercept, I meant to say a vertex of 1/2, 0, and it opens up. It has a y-intercept of 3/4, so it's going to cross somewhere around here, and what happens is that's where the vertex just touches the x-axis, so it only has one solution, or one 0, or one root, and that's at the value x equals a half. So there's number 3. Number 4, we have the opposite of 2 plus or minus square root of 2 squared, which is 4, minus 4 times 1 times negative 3. 4 times 1 times negative 3. All over 2. Okay, so let's clean up the radical part. So inside my radical, what do I have? And if I am multiplying 4, 1, and negative 3 together, I get negative 12. So that's my green part. So inside my radical, I really have 4 minus a negative 12. So this is going to be negative 2 plus or minus the square root of, and then it's 4 minus a negative 12. This is probably where most people make mistakes on the quadratic formula, the whole minus a negative part. So minus a negative, of course, that's just plus positive. So this is 16. So this is negative 2 plus or minus the square root of 16, which is a perfect square. That tells me this was factorable, all over 2. Okay, well that was negative 2 plus or minus 4 all over 2. So negative 2 plus 4 is 2 over 2. And negative 2 minus 4 is negative 6 over 2. So my two solutions are 1 or negative 3. Okay, and this was factorable. If you look up top here, and this is a pretty easy factorable equation. I'm not giant fan of when they put these in here like this. I guess it's good practice to use the quadratic formula, but this is factorable. If you were going to be asked to solve this, you always want to try factoring first because it's much easier. So this one factors x plus 3 times x minus 1, and there you see that's where your solutions come in. What makes x plus 3 0? Negative 3. What makes x minus 1 0? 1. So you can use the quadratic formula, but it certainly isn't the best method. All right, here's the last two, 5 and 6. Okay. All right, I'm back. My dog was barking at someone, so I had to take a break there. Excuse me. Number 5. Here we have the opposite of b, which is negative 3 plus or minus the square root of b squared. So that's going to be 9 minus 4 times 2 times 1. Okay, all over 2 times 2, which is 4. Now something a little different is going to happen here. When I calculate the value underneath my radical and I subtract 4 times 2 times 1, which this is value of 8. If I subtract that from 9, I'm going to get 1, which again is a perfect square. So we have negative 3 plus or minus square root of 1 all over 4. Okay, so this one wasn't necessarily an easy one to factor, but again, it could have been factored. And if you can't factor it easy, you can always just use the quadratic formula. It works for everything, works every time. So here we have negative 3 plus 1 over 4, or negative 3 minus 1 all over 4. And negative 3 plus 1, that's negative 2/4, which is negative 1/2. It's one of our solutions. Or negative 3 minus 1, which is negative 4 over 4, which is negative 1. So my two solutions here, my two zeros, my two solutions, my two roots are x equals negative 1/2 or negative 1. All right, let's go up to the last one, number 6. Opposite of b. b is 5, so the opposite of that's negative 5 plus or minus square root of b squared, which is 25, minus 4 times 1 times negative 3. All over 2 times 1, which is 2. Okay, again, I see here we're going to have a minus a negative. So be careful here. This value is going to end up being a negative 12. So I'm going to have 25 minus negative 12, which is actually plus 12, so it's 37. So negative 5 plus or minus the square root of 37 all over 2. Okay, 37 is prime, so there's no factors of 37 that we're going to be able to pull out and simplify. So this is in as simplest form as you can get, a simplified radical form. So therefore, you can just leave it if it does not simplify as x equals negative 5 plus or minus the square root of 37 over 2. So there's your two solutions for 5 and 6. Hope that helped out. And again, if you have any questions, feel free to post them on the Module 3 question board. Thanks for watching.